The energy possessed by virtue of its position or configuration is called potential energy. Now we have types of potential energy. It is of two types. First, gravitational potential energy. And second, elastic potential energy. Now, first is gravitational potential energy. It is denoted by U. We can define as energy possessed by virtue of its position. Virtue of its position. Let us consider the object is moving from ground to the point A. Total displacement is h. The weight of the body, mg, is acting downward. The body is moving upward and the force of gravity is acting downwards. Now, here gravitational force, that is mg, displacement is equal to h. So now we can write work done is equal to force into displacement. Force is mg, displacement is h. Here this work done is equal to, we can say, gravitational potential energy. So we can write here U is equal to mgh. Or we can write here U is equal to minus mgh. This negative sign shows that work is done by the gravitational force is in the opposite direction to the displacement of the object. Second is elastic potential energy. The energy possessed by virtue of its configuration is called elastic potential energy. Now, let us consider a case of a spring. Now, we can stretch or compress the spring. If we stretch the spring, then its length increases, and if we compress the spring, then its length decreases. Now, the force is applied on the spring, and due to this force applied, let x is extension. Now, according to Hooke's law, this extension produced is directly proportional to the force applied. Now, if we release this force, then the spring come to its initial position. Then it is only due to the restoring force produced in the spring. And now we can say that restoring force is equal to applied force, but direction is opposite. So we can write here this restoring force, we can write F minus F proportional to x, or we can write minus F is equal to k into x, or F is equal to minus k into x, where this k is spring constant or force constant. Now work done. To stretch spring. Let dx is small displacement. So we can write here dw f dot dx. F is dx cos 180 because direction of applied force and the restoring force, they are opposite. So now we can write dw, the value of f is minus k into x into dx cos 180 minus 1 dw, this is kx into dx. Now total work done is calculated by integrating the expression. So dw is equal to k x into dx from 0 to x, total displacement. So w is equal to k x square by 2. Now the work done is equal to elastic potential energy is equal to half kx square. So therefore u is equal to half into k into x square. This is the required expression for the elastic potential energy stored in a spring.